Hello, and I hope you're doing well today. We're going to take a look at this question, and in part A, we're asked to take the square root of 1 plus x over 1 minus x and show that it can be written in a different way like this. Well, first thing I'm going to do is separate it up into 1 plus x divided by 1 minus x, and I'm separated the square roots. So now I need to think, how on earth am I going to get this thing here? Well, if I times the top by 1 plus x, square rooted, that will sort that bit out. We'll get 1 plus x. And so to not change the fraction, I need to times the bottom by that as well. So that will give me 1 plus x. It's like, the square root of 2 times the square root of 2 is 2. So the square root of 1 plus x times the square root of 1 plus x is just 1 plus x. And then in here, I can actually bring this inside the square root. So it's going to be 1 minus x, 1 plus x. And then I can multiply this out, which is going to give me 1 minus x squared. This is a difference of 2 squares. So we're all set. These two are equal. I'm just going to write at the end that we need the modulus of x to be less than 1. Um, the reason being that it will be negative if it's not, which is a problem. So B is saying hence or otherwise find the expansion in ascending powers of x up to including the term of x to the 5 of this thing here. Now the hence is a big tip. You could do this by writing it as 1. Actually, let me write it. I'm going to go straight into writing it using index notation. So you could write 1 plus x to the half multiplied by 1 minus x to the minus a half, expand this one and times it by the expansion of that one. But you're going to get a lot of cross multiplying to do. You don't want to do that. The hence is telling us, actually, you know what? Use this result here. So I can write it as 1 plus x, and then it's going to be 1 minus x squared to the minus a half. This is much better because I don't have to do an expansion at the left-hand side, just the right-hand side. So remember, 1 plus x to the n. If you're expanding that where n is any real number, then we get 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 over 3 factorial x cubed, and so on. So therefore, just going to put that, sorry, I'm going to put this in brackets. That's just there to kind of help us. So for us, we're going to get 1 plus x. I'm going to leave that in this. And sometimes it's just good to kind of do this in isolation, but I think I'm all right. I'm just going to expand it out. So for us, we've got that instead of x, we have minus x squared. That's important. And then n is equal to minus a half. So it's going to become 1 plus n x plus n times n minus 1 x squared. So that's going to be minus x squared squared. Don't forget that. Divided by 2. Now the next term would be minus x squared cubed, which would be x to the 6, which is already too big because we're only expanding in up to power x to the 5. So actually, that's all I need to do. And I can just tidy this up now before I do my expansion. So 1 plus x multiplied by 1 plus a half x squared. And then this is also going to be positive because we're going to square a negative, and then we've got a negative times a negative. So it's going to be a half times 3 over 2, which is 3 over 4. Divide that by 2, 3 over 8. Remember, 2 factorial is just 2, so I haven't written the factorial there. And then this is going to be x to the 4. And now I've just got some multiplying out to do. So I'm going to get 1 plus a half x squared plus 3/8 x to the 4, and then deal with the x, a half x cubed, and finally we get our largest power, which is going to be 3/8 x to the 5. I'm just going to write plus dot 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 to show that it will continue forever. I think this should, it's good to tidy this up. So write it in ascending powers. 1 plus x plus a half x squared plus a half x cubed plus 3/8 x to the 4. Frustratingly, I can't quite fit that in. Plus 3/8 x to the 5 plus dot dot dot. Yeah, that's okay. And I think it's good here as well, just to write down the condition that the modulus of x must be less than 1. Well done.